Show that the a sub n term of the sequence 1, 3, 6, 10, 15, 21, is a sub n equals 1/2 times n plus 1. Observe that this sequence 1, 3, 6, 10, 15, 21, is obtained from a sub 1 equals 1. A sub 2 is 1 plus 2, which is 3. A sub 3 is 3 plus 3, which is 6. A sub 4 is 6 plus 4, which is 10. A sub 5 equals 10 plus 5, which is 15. And so we see that to obtain the a sub k plus 1 terms, we would take the previous term a sub k and add k plus 1 to it. For example, a sub 3 is a sub 2 plus 3. K plus 1, where k plus 1 is 3. And it is true because a sub 2 is 3. 3 plus 3 gives us a sub 3, which is 6. And this is how we generate this sequence starting with a sub 1 equals 1. To show that a sub n equals 1/2 n times n plus 1 is true for all n terms, we will use mathematical of induction. The principle of mathematical induction states that first, we have to come up with a statement for p sub n. This is the general statement. The statement p sub n is a sub n equals 1/2 n times n plus 1. We need to show that p sub 1 is true, and we need to show that if we were to assume it is true for p sub n, then it must be true for p sub n plus 1. And if you can show these two cases, this is what we call the base case, p sub 1, and the induction case, p sub n implies p sub n plus 1, then we can conclude that p sub n is true for all n, not just a particular n, but for all n. So to use principle of mathematical induction, we first state the statement. The statement about the natural numbers is that p sub n is the statement 1/2 n times n plus 1. We see that p sub 1 equals 1/2 times 1 times 1 plus 1, where n equals 1, and this is 1. This is a sub 1, so it is true. P sub 1 is true. So we showed the first case. Now we assume that this is true for a sub n, where a sub n is p sub n, which is 1/2 n times n plus 1. Remember that we assume this statement about p sub n only, one case p sub n only, not all cases n. We then use it to show that p sub n plus 1 is true. Consider the statement p sub n plus 1. What does p sub n plus 1 say, and how does it relate to p sub n? P sub n plus 1 is p sub n plus n plus 1. This is how we get the next term. Once we have a sub n, to get to the next term, we simply add n plus 1 to it. P sub n is 1/2 n times n plus 1. This is what we assume to be true. Plus n plus 1. We simply bring down n plus 1 and substitute p sub n with the statement that we assume to be true. There are two terms here, and both of the terms have n plus 1 in common, so we would factor out n plus 1. What we end up with is 1/2 n plus 1. We then factor out 1/2. We will keep n plus 1. If we factor out 1/2, then we end up with n plus 2. 1 half times n is 1 half n, and 1 half times 2 is 1. We can rewrite this as 1 half times n plus 1 times n plus 2, which is in the same form as 1 half n times n plus 1. And so the statement p sub n plus 1 also has the form, whatever the input is, 1 half of the input times 1 more than the input. And this is what p sub n says. P sub n says if the input is n, take 1 half of the input and times 1 plus the input. And this is precisely what the statement n plus 1 say. Take the input, half it, 1 half of the input, times, take the input and add 1 to it. To be clear, this is p sub n plus 1 equals 1 half times n plus 1 times n plus 1 plus 1. We assume only one case n is true, and we show that the case p sub n plus 1 follows the same rule as well. And again, what is the rule? The rule is that the case a sub n or the a sub n term is 1 half times the input times 1 plus the input. Since both of these two cases are true, the base case p sub 1 and the induction case where p sub n implies p sub n plus 1, we conclude that by the principle of mathematical induction, the statement p sub n equals 1 half times n plus 1, which is the formula for the n term, is true for all n. This is an example of a proof using principle of mathematical induction.